Good evening or afternoon, brothers and sisters. I'd like to welcome everyone to our safety webinar series for tonight's segment on fall protection. Thank you all for taking the time to join this important webinar. I am Jerry Sullivan, Executive Vice President of the International Union of Bricklayers and Allied Craftworkers. Earlier this month, OSHA held its national stand down for falls, where many workers took a break during working hours to focus on fall hazards and to reinforce the importance of fall protection. These stand downs are a necessary and important reminder that the construction job site can be inherently dangerous. In fact, in 2020, there were 1,008 fatalities on construction work sites. Of that number, falls from an elevated platform accounted for 351 of those fatalities. As many of you may know, fall hazards from an elevated surface is the #1 OSHA safety violation on construction sites for the 11th year in a row. It is also one of the leading causes of fatalities in the industry. These statistics are very alarming, especially when many of these accidents can possibly be avoided. In 2021, BAC tragically lost 3 of our own brothers due to a fall. We never want to hear that any of our brothers and sisters have lost their lives or have been severely injured due to a fall. We want everyone that goes to work to come home to their loved ones safe and sound. That is why we have committed to holding educational webinars throughout the year to share resources and tips and best practices to better help us understand how we can all stay safe while on the work site. Today, I'm joined by Lily Calderon, IU Manager of Health and Safety Programs, Dave Wysocki, IMTEF National Safety Director, Dave Donkin, IMTEF South Regional Training and Safety Director. Today, together, they will discuss fall protection systems, personal fall arrest systems, and fall safety on scaffolds, as well as sharing valuable resources to keep us safe. First, a few housekeeping items that I would like to mention. This webinar will be recorded and will be made available on the IU website for you to view, to share with our brothers and sisters. We will hold a question and answer session at the conclusion of the presentations. Please use the question and answer function at the bottom of the screen to make comments or to ask a question. We will address the questions in order they come in the question and answer portion at the end of the presentation. With that, I will hand it over to Lily.
Good afternoon, evening, brothers and sisters. Give me a second while I share my screen. Let's start. Can you guys see my screen?
Yes, we got it.
All right, awesome, thank you. Thank you, Jerry. Hello and welcome to everyone. I'm Liliana. I'd like to thank you for taking the time today to attend this webinar series on fall protection. It is important that we stay sharp out in the field. We work construction and hazards are all around us, as many of us know. The more we are aware to these hazards, the better we will be in assessing and preventing these hazards. Oh, I'm so sorry. Oh, there it is. I'm sorry. I do want to note for our Canadian members that may be on the line today that we will be referencing U.S. OSHA standards in these presentations. Canadian standards may differ from the U.S., but the hazards remain the same. And we hope that this presentation serves as a tool to better protect yourselves out in the field. With that, let's begin. So fall protection systems. What are, I'll be covering fall protection systems. Here are 2 questions that you can answer yourself in your head. See if you get any of these right. What are some types of fall protection systems, and who is responsible for providing fall protection? All right. So that's #1 question. Types of fall protection systems. We have guardrails, wire ropes, hole covers, and here are some pictures to show you that. On the left screen there is the wire rope system. With a top rail, mid rail, and that toe board. Over to the right upper corner, we have a wooden guardrail system, again with the mid rail top rail and toe boards, and verticals with no more than 8 feet span. In the bottom right-hand corner, we have a full cover, also guarded by a guardrail system, and it's properly marked as whole. So the second question.
Lily, I hate to interrupt you. We're getting a little message that says that there's a window on top of your PowerPoint. Are you using the mouse to forward, or are you using your arrow buttons?
My space bar.
Because I think it's opening a Zoom window on top, and we're getting a little error message. So if you try using your arrow buttons, it might not bring that window down on top, because it's on our end it's saying move this window away from the screen or something like that.
Okay. Thank you, Patrick. So second question, who is responsible? So OSHA standards state, which again, you can find these in 29 CFR 1926 Construction Industry Regulations and Standards book. You can find these there. The 1926 502A2 says the employer shall provide and install fall protection systems. I'm just going to read them down. The second one here is an excerpt. The employer shall provide a training program for each employee who might be exposed to a fall hazard. The third one, the employer shall ensure that each employee has been trained as necessary by a competent person, qualified in those following areas: the correct procedures for erecting, maintaining, disassembling, and inspecting the fall protection systems to be used. So the employer should be training you as a worker to use these. You can't possibly use the controlled access zone or guardrails properly if you don't know what you're looking for, right? If you don't know that you're supposed to have a mid-rail or toe boards, the employer needs to train you. So when do we use guardrails? Typically, we need to use them at the edge of a roof or at the edge of a leading edge. I know I've seen them around at every job site most of the time. If the general contractor is on their up to par, they'll provide it at any leading edge, right? We also see them in controlled access areas. So as you see in the second picture here, you have a ladder that's coming that's giving you access to the next level. So when you're walking up that level or you're coming down to that ladder, you don't want to accidentally trip or something and then fall out. So you have guardrails around that area, and also it's an open hole. And we have them around holes. So what are the guardrail system basics? Okay, you can find the regulation in 25 CFR 1926 502B. Okay, so we need an upper rail. The upper rail needs to be 42 inches plus or minus 3 inches, so anywhere between 39 and 45 inches, and it needs to withstand a upward or inward force of 200 pounds. Then we need a mid rail that has to be between the upper rail and the working area surface, right? So typically right in the middle, or at least 21 inches. And that needs to have a 150 pounds, can withstand 150 pounds inward, outward force. And then we need a toe board. It needs to be up about 3.5 inches with able to withstand 50 pounds of force. And now, like I mentioned earlier, our verticals can't span more than 8 feet apart. And this picture is pretty good. It kind of details everything the way that you should look at it out in the field. So if you're not seeing that, if you're missing a mid-rail, you know what happens when you don't have that mid-rail. If you accidentally fall, you might fit through that and fall through and into a lower level that could cause a serious fatality or injury. Now we're gonna look at a couple of pictures. You're gonna ask yourself if we're safe, if this person is safe. That first picture, what do we notice first? You notice he's not wearing a hard hat, right? I mean, safety first. Then we notice that he's out on the edge. There's nothing protecting him from falling. If he were to just lose a step for a little bit while he's plumbing his wall on the back end, what happens? He falls, and he's not up a foot, you know, he's up there. And the third thing we see here is there's no X braces in the back. That worker behind it, walking on that platform can, again, he can trip, lose his balance, and fall over, creating a fall hazard. The second picture, we see that there's a gap between the concrete posts, right? That exposes a worker to a greater fall of 6 feet. And also those 2x4s are not connected. So what happens when you put 200 pounds of force? Those are just gonna topple and you're gonna fall through them, even if you don't fit through between that and that concrete column or post. And it also doesn't have a toe board. Here, we're covering the hole, right? So we have a top rail, a mid rail, but what's missing? We're missing that toe board. I want to talk a little bit about cable guardrails. All right, as you can see on the left side, that person is holding those cables. It should not have a deflection more than 3 inches. These cable guardrails should be topped and secured. And the max deflection top rail with 200 pounds load. Okay, the second one on your right, I wanted to show you, because there's a tripping hazard into that hole. So yeah, you got the cable guards, but you can see that cable that can create a tripping hazard. Also, you're walking on that decking. It's not very stable. So just like wood guardrails, the top rail cable system must be at least 42 inches high and resist up to 200 pounds. Wire rope needs to be secured in top, like I said earlier. Should be sharper edges, burrs, or projections. And the guardrails, those cable guardrails must have the top rail flagged every 6 feet. As you can see in that picture, it's flagged less than 6 feet. You just can't be over 6 feet. And they added that toe board, which is great, because what happens if you don't have that toe board, tools, materials can fall down, and if there's someone working on below, that can create a hazard for them. So we want to make sure we have toe boards. Next, hole covers. A hole cover is a gap or a void of 2 inches or more. If you're gonna, when we cover our holes that are on the ground or in openings on the wall, they need to be securely fastened, and they have to be clearly marked hole or opening. What happens on the job site? Someone needs a piece of plywood, and they see the one laying there. It's not marked. They pick it up. They take it away, creating a hazard for someone else, because now that hole isn't covered. Or it can create a hazard for yourself, because you might forget it's there because you took that piece of plywood. So we need to make sure they're securely fastened and obviously marked, so that doesn't happen. These are just some of these fall protection systems. Next, Dave Donkin will just follow rest systems. Dave?
All right, thank you, Lily. All right, so like you said, Lily went over the conventional fall protection, meaning guardrail systems. So I'm going to go over personal fall rest systems. So personal fall rest system is one option. Give me 1 second here. Is one option of protection after controls have been put in place or when such controls are infeasible. Next slide. So in this slide, this just basically kind of goes over what we've probably in other safety programs where you've talked about the hierarchy of controls, right? So in this slide, if you look at the very bottom, you basically go over how the hierarchy of controls is regarding fall protection. If you see from the low end at the green, right, the most effective solution to eliminating a hazard, especially when it comes to fall protection, is elimination of the hazard, right? Moving forward, you get into something that's more passive, and that would be considered basically what Lily went over, and that's the physical barriers like the guardrail systems, etc. And then moving forward, you have your fall restraint systems. And then, as you can see there, as you start to get into fall restraint systems, you start to see a little bit of more things that are involved, and that's training required, right? So we're right here at the fall arrest systems. This is what we're going to be talking about. And then number 5 is administrative controls. So basically, if you work from left to right, basically, number 1, eliminating a hazard is the most effective. And as you work up in progression, fall arrest systems is like you're basically your last resort, right? Almost your last resort. So we're going to go over some of the requirements and some of the ins and outs of fall arrest systems. Next slide. Just as Jerry had mentioned at the beginning of the presentation regarding statistics, these statistics are from the construction face database. Falls accounted for about 42%, or about 325 of the 678 fatalities in that database. In the second bullet, I wanted to kind of mention there in the red is basically for 1/3 of those fatal falls from up to 30 feet and 26 from heights less than 15 feet, personal fall arrest systems were not even available to half of the people that fell, right? So they didn't even have the fall protection that they needed. Furthermore, in 1 of 4 of those falls, they weren't even using it at the time of the fall, meaning they might have had it on, they weren't connected, it's situations like that. And then at the bottom, about 70% were among residential contractors that included roofing, siding, and some sheet metal sector contractors, right? So pretty staggering statistics. Next slide. So we're going to go over for a little while there. It used to be the ABCs of fall protection. They've kind of increased that a little bit to add a little bit more components of what's considered personal fall arrest system. So we're going to go over the ABC and yes, even the E's of personal fall arrest systems. Next slide. So here's just a slide of some of the examples of what's considered the A part of the A, B, C, D, and E's. These are some various components that involve anchoring. You can see a gable clip there at the top. I'm sure some of you have seen those. If you look at the very bottom, you have the pipe clamp. You have a strap. You also have the insert anchor, and at the bottom there you have the beam clamp. These are all examples. In 1926 502, anchorages shall be independent of one another. They must support at least 5,000 pounds per employee or be used as part of a complete PFAS, which maintains a safety factor of at least 2 and is under the supervision of a qualified person, meaning that person, that qualified person must be the supervised at all times if you're just going to go with the maintaining of the safety factor for at least 2, right? Next slide. So this is just a slide, just to identify any hazards that we might see there. Go ahead and click it, Lily. Right. As you can see right there, they're not independent, right? They're not tied to their each independent anchorage point of at least 5,000 pounds. As a matter of fact, they're tied together, right? So if something was to happen, not only is one guy falling over, he's bringing his buddy with him. Next slide. Just as mentioned about the meeting of the 5,000 pounds for an anchorage point. As you can see right here, you just simply have a carabiner hooked to a basic 1 inch by 1 inch piece of metal strut. It's unfathomable to think that possibly that this meets the 5,000 pounds of requirement per the OSHA standard. Next slide. Again, another example of poor execution of anchorage point. I'm pretty sure that danger tape does not meet the requirement of 5,000 pounds for an anchorage point. Next slide. So we've covered the A, now we're on to the B. So now we're getting into the full body harness. So full body harness, number one, they're designed to hold the wearer upright, right, in the event of a fall. If you go back years past when in the era of the body belts, which really, if you think about it, wasn't that far long ago that they've been removed. I think it's probably like 1992, where you were able to wear a body belt. When you wear a body belt, you know, yeah, it might have held you, but most likely you would have been flipped upside down or contorted in any type of way. The body harness is designed to keep you upright. It also distributes the energy from the fall across the body of the wearer. It also comes in all sizes to accommodate all sizes of people, including harnesses designed specifically for women. And it also may be specialized based on the application in industries such as confined space and others. Next slide. So just as I mentioned before about the types of applications, harnesses must be matched to meet the application that they are. So harnesses are specifically designed for different industries. One of them being arrest, basically all fall arrest. You have a P type of harness, which is for positioning, pole climbing and formwork. You have a descent, which would be for an emergency evacuation. You also have something that's an E type of harness, and that could be considered something that's confined space access, where the D ring is actually the attachment point is in the center of the chest, as opposed to the conventional fall arrest type of harnesses where the D ring will be located in the middle of the back. And also they have ladder climbing for those who do a lot of the tower work, things of that nature, and also the R type of harness for rescue, which is tower rescue. Next slide. So as you can see in this slide, you have two different positions of somebody wearing a harness. Which one do you think is in the proper position for where the harness is supposed to be seated? Yeah, as you can see on the left-hand side, right, and on the right-hand side, you got the D ring, which should be closely centered in between the shoulder blades, you know, not down towards the middle of the back. In the left-hand side, if you were to fall in a harness, it's quite possible that you're just going to fall right out of that harness, right? It's not, it's going to slide off your shoulders, and then you're going to fall right out of your harness. Next slide. How about this setup? Do you think that they're wearing this properly? Next slide. So when it comes to personal fall arrest systems, and I don't know, something's blocking the middle of my top of my slides where I can't see up. Give me 1 second. I'm going to go to my own slides too. So when it comes to personal fall arrest systems, competent and qualified persons, if you read the language there, basically fall arrest systems and components must be inspected before each use and during each work shift for all the different types of damage that could occur. And that's anywhere from mildew all the way down to deterioration. Body belts and lanyards must also be compatible with all the connectors you use. One of the most important points to recognize, and I think Lily touched on this a little bit in the end of her presentation, was employers shall assure that each employee has been trained as necessary by a competent person, qualified and correct procedures for use, operation, and inspection of personal fall risk systems. In Lily's presentation, I just changed the language a little bit, but in that specific quotation out of OSHA standards, it says for all fall protection systems. I adapted this one to mention that for when it comes to personal fall arrest systems, that it's no different than any other type of any type of other fall protection systems. Next slide. So this is we're getting into the inspection and care. This is just a couple examples of some of what could happen with some of these harnesses. Keep in mind that the straps are made from synthetic fibers. Any exposure or overexposure to caustics, oils, and other chemicals will break down those synthetic fibers. So it's important to know that proper care and storage will allow for the longevity of the harness, and you should be inspecting the webbing for wear, cuts, burns, and any type of frays that are shown in a couple of these slides. Next slide.
1 second. Something happened on my end.
So when it comes to another inspection and care, regarding the hardware, right? So that's the hardware, considering like the buckles, anything that's metal in nature. You want to watch for any corrosion, some burrs, discoloration, deformation, cracks. As far as the software is concerned, and that would be a lot of your lanyards, again, the harness, the actual straps on the harnesses. You want to watch for any cuts, tears, burns, worn stitching, or any type of abrasion. Next slide. A lot of the manufacturers out there are so many different manufacturers of fall protection and PFAS, personal fall arrest systems. Each specific manufacturer are going to have these inspection lists, and you can go on the manufacturer's website to actually find these type of checklists for all parts of the PFAS. And that's the harnesses to the connections to the lanyards, etc. So next slide. And these are just some of the examples of a lot of the different manufacturers. Again, just a snapshot of a few of them. There's so many more out there. These are just some of the name ones that you would see if you were doing a search. Next slide. So we've got into the A, B, and now we're at the C. We're at the connectors. Some of the different types of connectors, as you can see on the left-hand side. Those are just some examples of them. When it comes to lanyards, they can come in various lengths. They're adjustable. They can come in, again, steel, web, or synthetic, with or without a shock absorber. And we'll talk a little bit more about shock absorbers a little bit later on here. When it comes to self-retracting lifelines, best suited to be anchored overhead. They minimize the swing fall, and they retract when they're not in use. As far as the lanyards are concerned, they're flexible line of rope, and it generally has a connector on each end, and is designed to prevent free fall. So something like this here on the left-hand side, that what we call the yo-yo or the self-retracting lanyards, and they're also similar to self-retracting lifelines, but they're sized a little bit smaller to allow for additional movement. Next slide.
Remove. Sorry there. I'm having issues on this side. 1 second. I'm going to stop sharing and reshare. Sorry, everyone. Is that good, Dave?
Yes, that's good. Yes. Yep. So again, this is just an example of the beam clamp that was mentioned earlier about the one of the anchorages. As you can see here, is there any potential hazard right here? Yeah, the potential hazard is the fact that you have that connection and that beam plate ends before the column. So in this situation, that beam clamp could slide off into that open end, hence resulting in a fall. Next slide. So we're into the D part of the PFASS. So this is the shock absorbers. By OSHA standards, they're designed to reduce forces of fall, can deploy up to a maximum of 3.5 feet, and they will limit the arresting force on an employee from about 900 to 1,800 pounds. And that'll, when the next slide will show exactly what that means. Always placed above the D-ring and not near the anchor, right? This is the part that needs to be connected to the person, to the harness, on the harness side of the individual, right? Not at the connection point. Next slide. This is just an example of what's considered an external shock absorber, where it's encapsulated in that sleeve. And then you have the internal shock absorber on the other lanyard, where it's already kind of built in to the size of the harness, to the size of the lanyard. Next slide. And just as I mentioned about the force that is exerted on the body when it comes to a fall or a free fall, with no shock absorber for the basic individual being 220 pounds at a fall distance of 6 foot with a steel cable lanyard, the arresting force, that means the force that is exerted on the body falling from that distance at the time of the stop is close to 7,300 pounds. With a shock absorber, it's taking that arresting force and basically almost 7 times, about 6 times less with the shock absorber. So you can see how it's decelerating that fall and hence less arresting force that is exerted on the body. And basically at the bottom there, to calculate arrest force with the shock absorber, you simply just multiply the weight of the worker times the free fall distance, right? So you can really easily just see based on your weight or somebody else's weight at 6 foot or even 10 foot for that matter, what the arresting force would be. It's pretty significant and grows exponentially. Next slide. So we've gone through the A, B, C, D, and now we're at the E, in which that's at what we basically say is what we're doing tonight, education and training, right? That's the part of that's been added to the personal fall arrest systems. Lily mentioned it before. It's unfathomable to think that everyone can understand the ins and outs of fall protection without being trained and understanding what is involved with personal fall arrest systems. Next slide. All right, and just for for you gamers out there or anybody who likes to try different things, this is an app that was developed. It's called Harness Hero, and it's a pretty interesting app. And if you were to take your phone and actually take your phone and scan that QR, it actually will take you directly to the App Store and actually shows you where you can actually download it to your phone. It's a pretty cool thing. It was developed basically as a game type of situation, but it's pretty neat in nature to see if you hook someone up wrong to a harness or you don't give them the right anchorage point, the things that can happen. So it's a pretty inventive way to learn about fall protection. So that concludes my portion. I'll turn it over to Mr. Dave Wysocki.
Thank you, Dave. I'm just going to turn my camera off here for unstable internet. So let me just close this off. Good evening, everybody. Thank you for joining us for this webinar. Lily talked about fall protection on job sites. We're in the construction end of it. When you get to general industry, they're requiring fall protection at 4 feet and maritime at 5 feet. So what I'm going to talk about is scaffolding and what type of fall protection is needed when we talk about scaffold. Next slide, Lily. So under the OSHA standard 1926 451 G1, it states that each employee on a scaffold more than 10 feet above a lower level shall be protected from falling to the lower level. So in your CFR or in the OSHA standard, paragraph G1, I through 7, if you go to the next slide, shows what type of fall protection is required on different types of scaffold. The ones highlighted are the ones we use the majority of the time: aerial lifts, obviously personal fall arrest system, a bosun's chair, personal fall arrest system. And there was a question in the question and answers about, what harness would be best for a bosun's chair. It's a personal preference when you're looking at fall protection, harnesses. We just attended a safety webinar, and the guy says, if you put a harness on and you feel comfortable, you put it on wrong. So any harness you would want to get, obviously the more money you spend, the more comfortable they are. But any harness will, keep it protected on the postage chair. Single and 2-point suspension scaffold. Obviously, you need both personal fall arrest systems and a guardrail system. Supported scaffold, depending on what type of scaffold you're on, you may need both, especially if you're erector dismantler, you might want to wear a harness and be tied off, building the scaffold. And for the most, once it's built, the guardrail system will be sufficient. Next slide. So some of the most common scaffold hazards out there, we're talking obviously falling off the scaffold is one, but also falling objects and falls from an elevated position. Some equipment related factors is improper use of guardrails or improper use of lifelines. Next slide, please. So here in this scaffold picture, obviously you can see there's an open end of the scaffold. They are tied off. You can see his lanyard is connected to the rope grab on his lifeline, but the end of the scaffold is wide open. They need to put some type of barrier up there. Next slide. So here on this picture, what do you see? What's not right? If you look at the right, they're both tied off to the single rope grab there. Those are designed for, one lanyard, one tie-off point, not for two people. Also, the scaffold, they got plank on there. It's not fully planked. There's no guardrails on there protecting them. Next slide, Lily. So some of the human factors when we come to scaffold and falling hazards is improper use of PPE or the inexperienced worker. Talking about the inexperienced worker, it is required that your employer shall train you on the type of scaffold you're going to be using and what type of hazards are associated with that scaffold. So, that is one of our keys at our training centers. We obviously want to train our members that, the proper either the guardrail system, personal fall arrest, and what type of fall protection is required on the scaffold. But unfortunately, it goes back to the employer because we don't know what type of scaffold we'll be working on. So, a person that's qualified on that job site should be training you. Also, lack of monitoring by the site superintendent. Next slide, please. So here's a picture. You got a guy sitting on top of the scaffold, definitely more than 10 feet. So he should have some type of guardrail system or some type of fall protection system. But there's also other hazards. You got vehicle traffic down below. I'm looking at the picture, there's probably pedestrian traffic down below. Lack of any fall protection in this one. Next slide. So Lily talked about the guardrails on the left. I'm going to talk a little bit about cross bracing on the right. Obviously, that's one question we get addressed a lot or asked a lot is why, we put the guardrails up, is that enough? Obviously, where the crossing point has to be between 20 and 30, the top 38 to 40, maximum 48, but also general contractors out there would want a mid rail put in there, whether it's a 2x4 that spans across the scaffold legs at that midpoint, because that is a pretty big area that someone could fall through. Next slide. Here's a little fatal fact. Miguel R. fell 5 stories to his death when his scaffolding collapsed. He was wearing a safety harness, but it wasn't tethered to the building. So here, obviously, he had the proper equipment, and Dave talked about in his presentation. We have the equipment. We just, we got to make sure we use it. So he had his harness on, but did not tie off. And unfortunately, they forced this worker with only 2 days on the job to pose to the foreman. So that can go back to the lack of training on the employer's part. Witnesses said the worker mistakenly stepped into an area where the plywood bridge was supposed to be erected, so obviously, untrained. Next slide, please. So when we're talking about scaffolding with a competent and qualified person, the scaffolds must be designed by a qualified person and must be constructed and loaded in accordance with that design. For employees erecting or dismantling supported scaffold, a competent person must determine if a greater hazard may result from providing safe access and fall protection measures. Next slide, please, Lily. So the competent person must determine the feasibility and safety of providing fall protection for employees erecting and dismantling supported scaffold. This question we get asked a lot about when you're building or erecting a scaffold. Does the erector have to be tied off? There is in the OSHA standard, for the erector dismantlers. If you go to the next slide, but there are ways that you could be tied off. This picture here shows people building a scaffold. There is a horizontal lifeline for the guys on top. Obviously, it's connected to a different tie-off point, not the scaffold. But if you look at the guy on the second level, he is tied off to the scaffold. We get that question a lot. Can we tie off to the scaffold? It is up to the manufacturer's recommendation that that scaffold meets the 5,000 pound tie-off point. Some of the resources where you can find some of these letters is on the Scaffold Access Industry Association website, the SIIA. They have a resource drop-down box. They talk about supported, suspended. They talk about fall protection and tying off to the scaffolding, but it's going to be up to the manufacturer's recommendation if their scaffold meets the 5,000 pounds. Also, when we're talking about, the fall protection when building and erecting and dismantling scaffold, a fall protection plan should be in place. Obviously that is critical to the safety of our members, the people building the scaffold, erecting or dismantling the scaffold. And that plan has to follow OSHA requirements depending on the type of scaffold that you are using. So one plan is not a one size fits all. It all depends on what type of scaffold they're erecting or dismantling, and they have to have a plan in place. One fact never changes. In the standard, it does say that fall protection for any employee on a scaffold more than 10 feet above a lower level. So they have to be tied off. Next slide, please. Here's the fatal fact. An employee was constructing the third level, a tubular welded frame scaffold. While standing on the second level, the scaffold was erected on a concrete floor. Each section was 6'5" high and was fully planked. He was setting a third level frame into the pins. On the second level, the frame flipped to one side. He fell to the ground and sustained a fatal blow to the head. So here, no tie-off point. There's a manufacturer out there that has a trailer fall protection. It doesn't go up to, I think it goes up to 20 feet, but they use it at residential. You back the trailer off. When they're doing shingling work, you could tie off to it. That could have been a case here where it could have prevented the fatality, or tying off to the frame. Maybe tying off the frame, he would have had a swing hazard, but maybe he wouldn't have hit the concrete. Next slide. So on this one, we look at the scaffold and we look at the guy standing on the gutter, not even standing on the scaffold. Is there a fall hazard there? Absolutely. You look at his plank on his scaffold, he's got the planking on the actual guardrail, the mid rail. But could you cite him for a scaffold hazard on his? No, but you could cite him for fall protection. He does not have any fall protection standing in the gutter. Next slide, please, Lily. And here's just another he's definitely above 10 feet, according to OSHA. Obviously there's a lack of fall protection. Falling object protection, there's nothing here, no netting. He's got that rake sitting on there, that has a chance to fall off of there. We as bricklayers, when we're working on the scaffold, one question we get a lot is, I want to stock the scaffold the night before. Well, according to the OSHA standard, any material shall not be stored on scaffolding or runways in excess supply needed for immediate operations. So meaning that you want to stock the scaffold several days in advance is strictly prohibited under the OSHA standard. And they also, in that standard, it's under the material handling, storage, use, and disposal. It also says a definition for immediate operation means work that will be done in the shift. So when we sit there and stock the scaffold the night before, that's fine, we can do it, but we need to protect that for falling objects. So we might have to put a screen up, some type of netting, make sure the toe boards are in place, so everything has to be in place in order for us to leave the material up there overnight. Next slide, please, Lily. So here's another fatality. A bricklayer crew built a 6-foot platform spanning a gap between two scaffold. The platform was correctly constructed. However, one of the planks was not scaffold grade lumber and also had extensive dry rot in the center. When the bricklayer stepped on the plank, it disintegrated and he fell 30 feet to his death. So when we're out on the job sites and we're talking about inspections, obviously here's one that you can look at it. You may think it's good, but we don't know what's happening on the inside of that plank. So that's why it's real important. Your competent person does, regular inspections or frequent inspections around the job site, and also use scaffold grade wood plank only. Next slide, please, Lily. So here we got a guy on the top of the scaffold. He's unprotected. He's definitely above the 10-foot rule, as OSHA states. Also, the guy on the right, he's kneeling down right below the forks. He has a cube of block there, but on each end of the cube of block is an opening for a chance for him to fall without any protection. Next slide. So here we got a hydromobile scaffold. They do have guardrails up on the scaffold, but there is no mid rail and no toe board. Missing guardrail, chance for someone to fall off of that. And also on the end, it's hard to see, but they don't have it blocked off. That person on that front can walk all the way to the end of the scaffold. Also on the bottom right of the picture, you see two plank sitting on an outrigger, and then on that outrigger, they have a piece of 2x4 on top of that. And there's also no guardrail on that end, with a chance that someone could walk to the end and fall off the scaffold. Next slide, please. And we'll talk a little bit about aerial lifts and scissor lifts. Obviously, aerial lifts, if you're getting in, whether that is or a scissor lift, you want to make sure that you are tied off prior to getting into the basket, and don't tie off until you exit the basket. Also, scissor lifts, if you have guardrails, you got to make sure that all guardrails are in place all the way around. Some of the older scissor lifts have chains. They did make a change that those are all going to be now a piece of steel or something hard, so they can't, no more chains. Using a body harness, obviously, or restaining belt with a lanyard attached to the boom or bucket to make sure that you cannot access or go outside of the basket. And with that, next slide, if there's any questions.
I want to say thank you to Dave Donkin and Dave Wysocki and Jerry Sullivan, and to you guys for taking the time to be here and listening in on this webinar. Our information is on the screen. If you have any questions, comments, concerns, anything you need, please don't hesitate to contact any one of us. And with that, we'll open up our Q&A.
Yeah. Okay. Thanks, Lily, Dave Wysocki, and Dave Donkin presentations. We can get started now with the Q&A. If you haven't already, you can submit any questions you may have for the panel using the Q&A feature at the bottom of your screen. So there was a first question there. I believe Wysocki answered it about the best harness for a Wilson chair. So with that, We have another question, one other question that was raised. In case of overhand bricklaying, is fall protection needed? I'm not sure who's going to handle that, but one of you can jump in.
So there's an exception to the standard of having to use guardrails in leading edge. For overhand, you can work without a guardrail system or personal arrest system if you set up a controlled access zone. All right, the controlled access zone is only for the people performing the work. No other trades, no other people that are not going to be doing the test can be in that area. For us, usually we put a barrier about 10 to 15 feet out so that no other trades and no other people can access that zone. But some general contractors will go beyond what OSHA states and will have you have 100% tie-up. When that happens, you have to follow the general contractor's safety regulations or safety standards. But most of the time, nowadays, at least the last couple times I was out in the field, we had to be tied off no matter what, no matter if there was an exception to this rule. I don't know if anyone else wants to add anything else.
No, I agree, Lily. It's going to be up to the general contractor. Obviously, we know OSHA's regulations are bare minimum. And general contractors definitely go above and beyond the standard.
Okay, another question. On more than a few occasions, I have seen iron workers unprotected without fall protection and harnesses, setting steel decking. Why is this legal? You're on mute, Dave.
I can grab that one.
Okay.
So basically for steel erection and any applications, OSHA acknowledges that when steel structure or the skeleton is built, the erectors, especially the connections, are at the top of the structure because they're building it as they go. So this makes the anchor points unavailable at foot level, and it makes conventional fall protection a little bit difficult. So therefore, they've established a 15-foot mark as the trigger height for fall protection for steel erection. So, and when it comes to metal decking, a controlled decking zone can be established as a substitute for fall protection when that metal decking is being installed and makes a leading edge over the work about 15 feet and up to 30 feet above the lower level. And with those controlled decking zones, there are additional requirements that are laid out. That and the 15-foot trigger height would be found in 1926-760 subpart R under steel erection. So that's where you would find that information.
Okay, thank you. Lily, I believe there was a question that you may have answered in writing. Did you want to address that?
Unmute it. Sure. Someone, does this webinar count as certification for fall protection? No, it does not. This presentation webinar serves as hazard awareness for all of you. At this time, we don't do certifications.
Right. Thank you. All right, there's another question. In the event of an accident and a person is hanging from a lanyard, do you assist in helping that person if possible?
I'll answer that. It's all going to depend on obviously you want to help out as best you can. If someone's hanging in the harness and you're there, obviously you're going to go back to your employer's fall protection plan. They have to have a plan in place if for some reason this is happening. If he's low enough and you have an aerial lift or something that can reach him, definitely take that aerial lift or scissor lift and try to get him out of that harness, from hanging there, because obviously we don't want him to get blood pooling in their feet. Hopefully he's conscious. Hopefully the employer supplies them with some of those steps that come right down, and you put them around your harness. You step into them, and you can take the pressure off your legs. But if you're there and you have like a scissor lift or something that can reach them, yes, definitely help that person out. But that employer should have a training plan in place.
Okay, Dave. There's another question that I'm not sure I understand, but it's what is the age of harness or lanyard?
I think what they're asking there is how long will the harness last?
That's what I figured
Usually
it was.
they give you a shelf life. Usually they say 5 years, but depending on, our PCC workers that use their harnesses every day, using chemicals, being out in the sun, heat, cold, you might have to replace it sooner than that. But most harnesses give you a 5-year lifespan. If you're only using it a few times a year, you can send it back to the manufacturer and they can inspect it and send it back to you. And you might be able to get another 5 years. It all depends on the use, how bad you use it and how bad you abuse it. Do you follow the manufacturer's recommendation for storing it, washing it, cleaning it? That's all going to play a factor in how long it'll last.
Also, as well, any type of personal fall arrest systems, anything that is part of a fall has to be discarded. It cannot be reused, and that includes everything. That includes the harness and any of the connectors, lanyards, etc. They need to be discarded. They cannot be used after they're subject to a fall.
Yeah, Dave's right. I mean, sometimes if for whatever reason it happened, there was a fall, you might not see wrong with the harness, but you don't know the inner linings of that system. So it's best, and you should always just get rid of it, because you don't know if it happens again, it might not save your life. It might tear, right? So we don't want that to happen. It's best just get rid of the ed system that took on that fall.
Okay. Unless any of the presenters have any closing remarks. And if there are no further questions, wait, I think one just came in. Asked by a contractor if OSHA has standard that covers tool tethers for falling objects. Is anyone aware of one?
I don't know if there's a standard for tethering tools as of right now. I know that there's a lot of manufacturers that are starting to implement a lot more of the processes for tethering tools. Pete Cole has a good bit of information. He actually has a bunch of the tethering for the tape measures. 3M's developed a bucket that you can dump the tools into, flip the bucket upside down, and the tools don't fall out of it. As far as a standard, a standard has a lot of things to go through first before it comes to standard. So that involves conversation, that involves ANSI testing. So there's a lot more to getting into the standard, but I don't know, Dave, specifically if they've written a standard for tethering of tools as of right now.
Yeah, there's nothing as far as, but I mean, when you look at the OSHA standard for the falling object, they're including tools in there, a hammer, whatever type of it. You got to somehow protect that from falling, whether it's a safety net, and obviously, like you say, 3M donated three of those buckets to us, and it's all for tethering tools, like Dave said. So that would be one type of a fall protection system that would prevent that object from falling. And where that came from was a tape measure that fell off a guy's hip, went down 25 feet. It hit a scaffold leg, a 6-foot buck, shot out about 20 feet, hit a UPS driver in the temple and killed him. So the 3M, they're kind of in the forefront of all safety equipment. They did come up with that tethering bucket, which has all kinds of tapes, for hard hats, pencils, tape measures, you name it. They got some type of fall protection tethering piece, that could be used. But they're going to go back to the falling object standard under the fall protection. So.
Right, and while OSHA doesn't have a standard, again, the GC might have, their thing is that you have to tether all your tools. Lend-Lease out in Chicago, when I was out in the field, if you were using a tool, they wanted anywhere up on a scaffold, whether you're on a ladder, wherever you were, they wanted you to tether all your tools. So it could be that the GC is requiring it. Well, Really doesn't matter whether OSHA has it or not. If they're requiring it, then you have to adhere to their safety regulations.
Yeah, Lily, I believe that there was some talk on our National Building Trades Health and Safety Committee regarding trying to make it a standard or trying to move forward with all tools being tethered. There was a lot of discussion about that. I think they actually put together a group, subcommittee group. With that, I see no further questions. So we'll close by thanking Lily Calderon, Dave Wysocki, and Dave Donkin for their hard work on putting this webinar together for us. The International Union appreciates participation today. Hope you found the information useful. Feel free to reach out to Lily, Dave Wysocki, Dave Donkin, or myself for additional information. Thank you, everyone. Stay safe.
Stay safe, everyone.